Now we need to do the cruise leg calculations. For Foxtrot Quebec Delta, our midpoint that divides our two cruise legs, we need to select a cross radial to verify when we are there. Note the closest VOR to FQD is Sugarloaf Mountain. However, if you read the NOTAMs, you'll find that it may not be a reliable source of navigation. So that's an important note to make sure that there are no notices to airmen that will interfere with your ability to use a particular nav aid. In this case, let's go ahead and use the Charlotte VOR. Running a quick measurement from Charlotte, we can see that it's 50 some miles away, which may make it a less ideal source of navigation as well. So we'll go back to the first one that we used, Spartanburg downtown. Taking a measurement from the center of Spartanburg to the center of our point, drawing a light line for reference, we can see that 004 radial from Spartanburg should be our cross reference for FQD. So SPA, 004 degree radial, same frequency, 115.7. And I put that in the wrong blank. It should go in the blank that is half a space above the waypoint. Okay. Now, we need to do the calculations, time, speed, and distance. In the previous two waypoints that we've calculated, top of climb and top of descent, we found the speed first, then the time, then the distance. For these two legs, we already know the distance. Once we find the speed, we will then use those two values to calculate the time. So, we already determined that our true airspeed, according to the cruise performance chart, would be 110 knots. Cruising at 5,500 feet with standard temperature at 2,500 RPM, we should see 110 knots of true airspeed. Aviation Weather Center shows us that near GSP, the winds closest to our cruising altitude will be 250 at 21. So we'll go ahead and put that down here, 250 at 21 knots. And the temperature will be plus 3 degrees Celsius. For both of these legs, since GSP is the closest, the wind should remain the same. However, on a longer flight, you will want to make sure that you're using the most accurate winds aloft numbers possible. Now, our true course of 032 remains unchanged. However, the wind correction angle may be different. So, back to this side of the E6B. We're going to start by setting the wind direction of 250 underneath the true index. Once we've done that, we're going to mark the wind velocity up from the center point. We said that was 21 knots. Then set the true course of 032 under the true index. Slide the wind velocity mark to the true airspeed of 110. Read ground speed under the center, 122.45. 125 knots of ground speed, and a wind correction angle of 246 minus 7 degrees. So that gives us 025 for our true heading. Variation remains unchanged, 032 for our magnetic heading. Deviation remains unchanged, so 034 will be our compass heading. Since the winds are the same and the true course is the same, our second waypoint will have the same values. I should say our second cruise leg, not our second waypoint, and the same ground speed. Now that we know our speed and our distance, we can calculate time. So, flip the E6B over, put 125 knots under the black triangle, 125 under the black triangle, read distance on the outer. Our first distance is 24. So, distance of 24 miles is 11.5 minutes. We'll call that 12 minutes of time. And for the next leg, 125 under the black triangle will result in, at 15 miles of distance traveled, 7 minutes of time.